This is pre-calc. This is lesson 2 of the second half, I think day 2, right? So we're going to finish this up. Today we're going to talk about first is radicals. And the first box here just kind of outlines the fact that if a and b are both positive, if I take the nth root of a, it will equal b. But it also means on the flip side that I can take that value that would have came out, the answer, and bring it to the nth power. So now it's not the root anymore, it's the power. I'll get a back. Yeah, that pretty much makes sense. So looking at our example there, I'm sorry they're kind of small on the screen. That's the fourth root of 81. The fourth root of 81, aka what times itself 4 times is 81. It's 3. It says that. It's given to us, is 3. So what does that mean? That means 3, well, gotta switch here. 3 to the 4th power will be 81. Yay? Nay? Makes sense? I mean, you guys have dealt with things like that before. Now, we can go on to the other example there that says the cubed root of negative 8. Essentially ask yourself, what times self 3 times is negative 8? It ends up being negative 2. What does that mean? That means negative 2 to the 3rd power is equal to negative 8. Now remember, I think it's going to come up in this next slide or two, that an even root, so square root, 4th root, 6th root, only works with positive numbers, but you actually get 2 answers. Like a square root of 25, it should be plus n minus 5, right? If you're solving for an equation. So when you have to take roots, usually because we're solving for an equation, there's always a plus and minus. When you're taking an odd root, 3rd root, 5th root, 7th root, there's only 1. Hence, we only have 1 answer here for, and it always is an answer, sorry. There's always an answer. The 3rd root of negative 8 is negative 2. It works. But if I asked you what's the square root of 8, you say what? Square root of 8. Okay, square root of negative 16. No, square root of a negative 16. It's plus or minus 4i or 4i, right? It's not real. So there's only one real solution when taking an even root. Odd, there's always an answer. Always, always, always. That's all I wanted to highlight there. So, I need to fix this. So this one is some more helpful properties of exponents into one place. This is all about roots, nth roots. Guys, remember that rational exponents end up forming roots, nth roots. And so when I say number 1 there, and I see that the nth root of 2 numbers being multiplied together, you can separate them to their own, because that's just a product of powers, or no, sorry, power of a product, right? That's just saying an exponent on a group. That group gets the exponent brought in. We call that distributing it in, but it really wasn't distributing. And the same thing with number 2, we just deal with the fraction. If I have a power on a fraction, I bring it in. Now it's the root on a fraction. The top and bottom get that root. And part number 3, if I have nestled roots, I can just take the roots and multiply them together. These are all things that kind of make sense. 4 and 5 talk about the idea of, is there a positive answer or a negative answer? Remember in 5, if n is even, you always have a positive answer come out. So, looking at this, we want to simplify exponent using the exponent properties. I'm going to show you 2 different ways. So I'm going to zoom in. The first way is going to use the actual properties as listed above. The first property that they had on our box said that if I'm multiplying multiple things together, I can separate them, right, to their own root. In this case, I got the cubed root of x to the 4th. So, this is what I propose. I propose that we take x to the 3rd out and separate that from x. Is that okay? And if you looked at one of the other properties, if you take the cubed root of something to the 3rd power, they will cancel. So those two will cancel each other away, leaving you with x. Can I simplify the cubed root of x anymore? Negative. So therefore, you have an answer. Works out fine and dandy. But what's going on tonight? There's a football game and then there's a dance. And if you've had me before, and I know some of you guys have, we've gone to the dance before. We've gone to the square root dance. We've gone to the cubed root dance, fourth root dance. This rule for the dance, though, is that you have to have a partner or the amount that the root says. It's kind of like the little bouncer at the door who says that in our problem here, you need to have 3 of you to go. And if you don't have a group of 3, you don't get to go. You got to stay home. And so, let's try this differently. What does x to the 4th really mean? Right. It's x times itself. 1, 2, 3, 4. 4 times. Usually when you're dealing with variables, it's pretty easy to break them up. The next problem deals with numbers, and so we'll deal with it when we get there. We're going to make factor trees. What I propose on this is you go back and say, okay, why did I put 4th in there? I'm not sure, guys. Oh, I'm really messing with this now. And it should be the 3rd power, right? 3rd root. What I propose is that you go and group them up. The bouncer says you got to have 3 of you to enter. Do we have that option? Is there 3 of the like terms? Yes. Those 3 people get to go to the dance. They get to go out. The x on the end, does he get to go? No, he has to stay home. He has to stay inside the cubed root. So he's going to stay inside the cubed root while his friends go to the dance. But when they go to the dance, they're all going to join hands. And they become one factor of it. And so, boom, x times the cubed root of x. It's the same thing as we have listed above. So 2 different ways, 2 different approaches using the same exact rules. Make sense? Now, we want you to simplify the square root of 32 plus the square root of 200. I've asked you already before, I think I said something earlier, one of the earlier lessons, about remembering your perfect squares, probably up to around 1,000. Did I say that? No? Okay. Probably a good habit. Because I can use rule number 1 that we had up there and separate any perfect squares out because we know the square root of perfect squares. That's one option. The other option is to make a factor tree. What's the factors of 32? 2 and 16. Because the whole idea here is to find partners. Well, 16 is 2 and 8, 2 and 4, and 2 and 2. Is that the only factor tree that I could have? Your branches could be different. You could have went with 4 and 4, but then you still would have ended up with 4 of the 2's left over at the end. Now, we could have stopped at 16. Because 16 is a perfect square. 16 could have went to the dance and became a what? A 4. But in this method, I now have the square root of 1, 2, 3, 4, 5, right? 5 2's. At this dance, what's the requirement? Got to have partners. So I got a group here, I got a group there. The last 2 has to stay home. So, when this group leaves, they become a 2. This guy who gets to leave, that group goes, and they also become a 2. So that means I have a 2 and a 2 on the outside, and square root of 2 has to stay home. And 2 times 2 is? So I get 4 square root 2. That's the first part. Now I get to do the same thing with 200. Let's make this one go a little bit better. That's 2 and 100. Yes? That 100 is 10 and 10. Can I stop right there and say, I have partners? And those partners will leave and become a 1 of the 10's. And who's staying home? 2. Hey, oh wait, I put that in the wrong spot. Sorry. I'll move it. Watch that. Oh, what is all that other stuff in there? There we go. And now you have 4 of something plus 10 of something. You now have 14 of something, and those somethings were square root of 2's. Now we can talk about the idea of there are different forms. We have exponent form, which is a to the 1 over n. And we have radical form, which is the nth root of a. You can interchange them at will. Now, they're not always that simple. They're not always just 1 over 2 to give me the square root. Sometimes there's an actual fraction as an exponent. And what you see is that we have two other forms then. We can take the m, which is in the numerator, and keep it on a inside. Or put m on the outside as its own exponent. Okay? Now, for the second group there with the fractional exponent, both of those will have their opportunities to be very useful for us. Because for me, to find a square root or a cubed root of a number, the smaller the number, the easier it will be. So generally, I'll keep the power of m on the outside because I want to take the root of the smallest number possible because I know those. So, hence, let's talk about the first example. 8 to the 2/3 power. Most of us, right off the top of our head, wouldn't just be able to do that. But what we see is that we have an exponent with a fractional, or a power, and so split it up. There are two different ways to write this, right? There's 8. Now wait a minute. Why do those work? It's because, could I do this, guys? Is that okay? Right. That's just using power of a power. I'm just going to on-divide them, or on-multiply them, right? And so this would end up being 8 squared to the 1/3 power, or cubed root, right? That's one option. The other option is doing 8 to the 1/3 squared, which would equal what? The cubed root of 8 squared. Essentially, both of those are the same, yes? But what's easier? Squaring 8 first and then trying to find a cubed root, or find the cubed root of 8 and then square it? I think taking the cubed root first. Now, 8's a pretty simple number. Most of us hopefully recognize that 8 squared, I can do that in my head, which is 64. What times itself 3 times is 64? That's a little bit trickier. The answer is 4. Oh, wrong place. 4. But what's the cubed root of 8? 2. And what's 2 squared? 4. So both of them get you to the same exact spot, but one will definitely be easier. Moving on to that next one, it's 125 to the negative 1/3. What should I do first? Something with a negative. I don't like negative exponents, so it goes to the bottom. So it should become 1 over 125 to the positive 1/3. If you feel inclined, you can change that to the cubed root of 125, and what times itself 3 times? So it ends up being 1/5. Now, I told you guys that I accidentally gave you a problem like C in your homework, I think, last night. This one's a pretty simplified version because all of our exponents have what? Common denominator. If they didn't, you just need to get yourself a common denominator. Are you guys at the point where I can do all of that at one time? I can add across the top and subtract the one on the bottom. So, you end up with a to the 2/5 plus 7/5. Gosh, it'll work, guys. And minus 3/5, which then is a to the 6/5. Do I need to change it? Is there some way I can simplify that? Probably not. Now, the big question would be, should we leave it in exponent form or should we switch it to radical? follow your directions. For now, we can leave it here. If I wanted to, this would be the 5th root of a to the 6th power, or the 6 can be on the outside of the whole entire root, correct? Yes. D, I think the only problem with part D is the fact that it's got a fractional exponent on a group. So what do I do? Just distribute that 3/2 in. It makes no difference. But don't forget that you have to do it to all of them. And what's 3 times 3? So it'd be 9/2, and b to the 6. I am perfectly fine with this so far, because everything's variables, except for the 2. What would be a little bit more simplified or better answer for 2 to the 3/2? 2 times the square root of 2? I don't know about that one. Because it's not. It is a square root. Okay, that would work, right? Yep, right. But what if I wanted to keep it? Actually, probably that would be the best answer, wouldn't it? But how did you get that?
You take 2 of the, so it's square root of 2 cubed, and then you take 2 of the 2's out.
2 cubed, which means I have 3 2's. 2, 2, 2. There's a partner, isn't there? So yes, I actually do like this. Sorry, I told you no at first. And it'd be 2 square root of 2, and then the rest of it. A to the 9/2, b to the 6. Did everybody follow what we did there? I think in first hour I left it as 8, the square root of 8. Obviously it's not reduced. Always reduce. And then the last problem on this page is a nestled square root. To simplify this one, switch everything to exponents. Can everybody see that the first outermost exponent is a square root? Which would be what power? 1/2. Working my way in, I have an x, and then another x to the 1/2. And then all you have to do is what? There's a couple options here. I could distribute the 1/2 here through, right? Or could I add these two together and then multiply? It doesn't matter which way you go. If I'm going to add them, I have to have a common denominator. It is 1, so 2 divided by 2. So it leaves me with what inside? X to the 3/2 inside to the 1/2, which then equals x to the 3/4. And the last one for this lesson is rationalizing the denominator. Guys, we don't like square roots on the bottom. And square roots would also include i's, because i's are what? They're imaginary, but it's what? Square root of -1. So square root of -1, it's a square root, so therefore it's on the bottom. We don't like it. Now there's 2 different camps here. You get the easy camp, where it's just a square root on the bottom. To get rid of a square root, remember we're dealing with fractions, so you can't just square the top and the bottom. That changes it. The only recourse I have is to add something to the top. No, you can't add something to the top and bottom. You can only multiply or divide something to the top and bottom. Yes? But you have to do it in a way that doesn't change it. So you have to do the same thing to both. What times square root of 3 will make it a nice number? Square root of 3. And so I multiply by square root of 3 over the square root of 3. Multiplying across, you get square root of 3 over 3. We've done something like that with the 1 over square root of 2 a lot last year. The next one. This is the one that gets a little bit more in depth. It gets a little bit tougher because people forget how to FOIL. The bottom on this one is not just a square root of 2. Because if I multiply the bottom by square root of 2, and I'll do that here, I would have to distribute, right? If I multiply square root of 2 times square root of 2, I'm fine. Yay, it disappeared. I wanted that. But unfortunately, the square root of 2 also gets multiplied to 1, which reintroduces square root of 2. Not good enough, so don't do that. What do we have to multiply this one by?
1 minus.
Yes, it's conjugate. You have to multiply by 1 minus the square root of 2, but what you do to the bottom, do to the top. Distribute gets 2 minus 2 square root of 2 across the top. The bottom you have to FOIL. First outside, inside, last. 1 times 1. 1 times negative square root of 2. Square root of 2 times 1. And negative, positive square root of 2 times a negative square root of 2. So negative square root of 4, which is negative 2. Hey, we like that. Hopefully everyone sees that. We just basically created the sum and difference, yes? We're going to talk about that in lesson 3, when you guys have to FOIL and multiply or divide and factor things. But that means it's 2 minus 2 square root 2 all over negative 1. We're not leaving it like that. So, negative 2 plus 2 square root 2, and we call it our day. So, homework is lesson 1.2, day 2, page 23, 1, 10, 11, and 42 through 66 every 3. Have a fantastic day.